Biomedical engineering is one of the fastest growing engineering fields today. It's truly the engineering field of the future. In fact, this century is being called the century of biotechnology. To give you an idea of the scope of this field, take a look at all these career opportunities. Biomedical engineering is interdisciplinary and brings together engineering with the biological and medical sciences. If you want to apply knowledge from a wide range of engineering disciplines, mechanical, electronic, computer, chemical, then biomedical engineering can hold exciting possibilities for you. Let's meet some biomedical engineers and hear their stories.
In my job, I support a division of Medtronic that makes internal implantable defibrillators. The external defibrillators, the ones that have the paddles, that's what most people are familiar with today from television and such. And the device that we make is actually an internal one that is implanted underneath the skin up in this area, just like a pacemaker. And it's like having a team of paramedics walking behind you with an external defibrillator, but it's implanted inside. And so what it does is it monitors your heart rate on an ongoing basis. And when it goes too fast, which is what a defibrillator treats, is it treats heart rhythms that go too fast, then it delivers a shock to the heart directly.
Yes, it does hurt. So, and that's why what we have is called tiered therapy. And so what they try to do is they'll pace the heart, and the patient will most of the time not be able to feel that. And then if that doesn't work, then they go to a more aggressive therapy, and then the last therapy is the shock, which is anywhere from like a 30 joule to a 35 joule shock, which is 600 to maybe 750 volts across the heart. And part of my job is working with the customers or working with the patients as a support role. And so what the patients will oftentimes tell me is that it feels like getting kicked in the chest by a horse. The alternate case is, a lot of times death. So it's kind of the last resort, but a lot of the patients are very sick, so that's the treatment that they need.
I think the best part of the job is seeing the products actually being released in the marketplace and serving patients. I mean, some ideas that I've started with that are just crude, raw ideas are now in thousands of patients around the world and improving their quality of life and giving them an extension of life.
Another area where I think that biomedical engineers are going to have an enormous impact is tissue engineering. Right now, engineers are working very closely with physicians in order to be able to, for example, grow a new liver for a patient that requires a liver transplant. As I'm sure many of the people are aware, the demand for transplanted liver far outpaces the supply of livers that are available. If the biomedical engineer can actually grow a liver that's specific for a patient, then we will overcome that problem of supply and demand.
My research group is one of the main areas my research group is working on is in the development of tissue engineered bone, where we take materials, take cells and these synthetic polymers that we've developed, bring them together to regenerate different bone type tissues. And that follows right in line with my work as an orthopedic surgeon. Most of these implants stayed in the body and didn't go away. And actually, it'd be far better if one could have an implant that you place in the body and over time it degraded away or it dissolved away and was replaced by the body's own tissues. And that's an object of some of my research. We've developed new synthetic materials, synthetic polymers, and these are long chains of carbon that we can actually place inside the body that actually go away over time and reconstitute a tissue. The alternatives that we have right now for making bone are using autografts, where we actually take bone from one part of a person's body and bring it to another part, which may hopefully 10, 20 years from now seem barbaric, but right now this is what we do. And I think that we've been working in this area for about 9 years now, and we've made strides and developments all along the way, and I feel fairly confident that we'll be able to have a synthetic structure that will be able to replace bone.
Biomechanics of injury is a field that attempts to understand the way mechanical forces interact with the human body. Ordinarily, forces that we experience tend to make us respond and grow and become stronger, but when the forces exceed the tolerance of our tissues, then we get injured. And it's trying to, the field of biomechanics attempts to understand the levels that we can withstand and make design changes for the environment that we live in to try to avoid those forces.
Right now we're trying to help physicians to improve their diagnostic ability, to be able to look inside the body without having to use a knife. When a physician does a diagnostic ultrasound scan, they take a picture of the internal organs of the body. And what we would like to do is develop an agent which the physician can inject into the patient just before doing the ultrasound scan, which will pass through the organ that the physician is looking at and greatly increase the contrast of that picture. So the physician will be able to pick out, for example, small tumors in the liver, which right now she or he cannot do with the ultrasound.
I'm responsible for doing daily quality control on the blood processing equipment there. We have a blood gas analyzer, coagulation machine, and some oxygen saturation monitors that determine oxygen saturation of the blood. Beyond that, I support all of the variety of equipment that they utilize in the cardiac cath lab. The next procedure is a patient who has pulmonary stenosis, which means they have narrowing in a variety of areas in their pulmonary arteries where the blood feeds from their heart into the lungs to be oxygenated and returns back to the heart to be pumped out to the body. They'll have a variety of constrictions in that plumbing system, and they'll attempt to first measure it by injecting a radio-opaque contrast under radiographic imaging to visualize what they're going to be working with. And depending on what they observe, they'll first try ballooning the area using standard dilation techniques, and hopefully the area will remain open. If not, they'll be implanting stent devices which will hold the artery walls open.
This patient was in a motor vehicle accident and tore some of the soft tissue structures inside the knee, specifically something called the meniscus, which is, it looks like a shock absorber of the knee is torn. And also, we think that she's also torn something called the cruciate ligament. It's a ligament that makes a cross across the knee, basically. And our plan is to actually go in and trim the area that of the meniscus, that shock absorber that's torn, and also tighten up that area that's torn of that ligament, the cruciate ligament.
Take the medical school courses, take whatever courses that you can find to learn about the workings of the body. And this is important because once you get to the point where you're working in the field of biomedical engineering, it's not enough just to be an engineer. You have to understand what the person who's using what you produce is going to do with it.
A lot of colleges have internship or co-op programs where students can get involved in that. And that's the opportunity for the student to work and then come into work for 6 months and then go back to school and then work. So they're alternating, a work-school schedule for about 2 years.
Number one, I would highly recommend to call the local hospital and say, can I volunteer? Can I come and be part of your team for a couple of weeks, maybe in the summer? Can I maybe look at the biomedical engineering program if you have in the local hospital? And I'm sure they will be very happy to accommodate you.
The biomedical engineering is going to be the engineering of the future. If we read, for example, in Time magazine and the news reports, there are very often reports on the bionic person or the biomedical breakthrough of the future. More and more we're seeing that the cutting edge research is integrating biology with engineering.
I don't think that anyone can predict what the frontiers will be in combining engineering and medicine and the life sciences areas, because each day we come up with something new that's just mind-boggling.
Just thinking about being able to regenerate different types of organ tissues that heretofore cannot be replaced in terms of kidney, liver, bone, very, very important, of course, cartilage, ligament.
The things that are real exciting is genetics, is gene therapy, is looking at what can we learn from DNA, what can we learn to not only make devices that can treat problems and treat health issues, but actually designing therapies that actually can cure people.
I am involved right now in something called telemedicine. This is a new wave where you can consult with patients halfway across the globe or from the top of the Everest. You can provide distant learning for biomedical engineers in Saudi Arabia, like we do from Houston, Texas, via this system of television, monitor, and satellite.
I think these areas are going to be fantastic in terms of being able to, one, extend life in terms of treatment of different disease disorders, and number two, improve the quality of life for people, which is what we're really all about, both as engineers, biomedical engineers, and also as physicians.
The thing that I like most about being in biomedical engineering is that I get to combine knowledge from a number of fields and bring them all together.
I'm constantly challenged mentally to think up new solutions and to come up with like way cooler ways of doing stuff. You know, it's like no matter what you do, there's always something more to do, and there's always something more challenging.
We're making products that are improving or helping somebody's life or improve their quality of life, and I don't know of any other engineering position that directly affects humanity or people in that aspect.
You really look forward to going to work. It's a fun area. You're doing good. You're doing the right thing, and you are really helping people. You really are contributing and helping people.
We have a program around the holidays when we invite patients back to come and talk to us, and to see patients just truly thanking you from the bottom of their heart that they have these products and how fulfilled their life has been after their first event, it's rewarding.